So the next speaker for the session is Dr. Saikranthi. She is a faculty colleague at the Department of Earth and Climate Sciences, IISER Tirupati. She did her doctoral thesis from National Atmospheric Research Laboratory, NARL Gadanki. Her research interests lie in the area of remote sensing of cloud and precipitation. Today she is going to talk to us about sub-daily scale rainfall extremes in India. Saikranthi, over to you.
Good morning to all. I thank Indian Academy of Sciences for giving me this opportunity to present my work. Today I am Saikranthi from Department of Earth and Climate Sciences. Today I would like to talk about sub-daily scale extreme rainfall events over India that occurred over a few decades. So as we all know, in the recent decades, the extreme rainfall events are increasing, and also the Intergovernmental Panel for the Climate Change, IPCC, has highlighted the increase in the number of these extreme rainfall events, which is very important. And they also said that because of the climate change, this extreme rainfall events will increase in the future as well. And also the observational trend analysis is very much loss in India and as also the elsewhere. So now, here are some of the extreme rainfall events which is associated with the floods are listed here, and there are many more too. So 90% of the catastrophes that are caused by these extreme rainfall events that we could see, and also the loss from these extreme rainfall events from India occupies 10% of the global economic loss. So this is very significant, and not only the economic losses, and also this extreme rainfall events has an impact on the agrarian countries, especially like Indian countries, that I could say, like it affects the agriculture in the form of like the occurrence of the extreme rainfall events, and also the crop. They are anti-correlated with each other, because we have seen the extreme rainfall events occurrence is increasing. It impacts on the crop yield as well. So over Indian region, this is one of the extreme rainfall events occurrence is one of the important topic that has to be analyzed. So many pioneering studies exist that has studied about the occurrence of the extreme rainfall events and the trend analysis as well. People have seen that the extreme rainfall events are increasing with respect to the years for the past 2 decades, and also there exists the spatial variation in the trends, which is very different from the central India to the southeast peninsular Indian region. So while studying this extreme rainfall events, people have used the daily accumulated rainfall to calculate these events. But in the recent years, we see that the rainfall that is occurring over the longer durations is reduced, and we have very short scale events which cause the flash floods basically. So what we have chosen was to study the sub-daily extreme rainfall events, which significantly affects the flash flood intensity, not only over the urban areas, even it's a problem for the rural areas as well. So we have used the hourly IMD rain gauges data for over the long term data set is used to study the trend analysis for this, and also we have compared this IMD observations with the CMIP6 models, both historical and the MIP models for this. And also when this extreme rainfall events occurs, we notice that there is a large impact on the surface essential climate variables as well, especially radiation components and as well as the soil parameters. So we have quantified using the observations that we have at IISER Tirupati that I'll be explaining. So thanks to Indian Meteorological Department, which has a wealth of long-term rain gauge stations that is all over the India, that starts from 1969 to 1910, which covers almost 40 decades of the rainfall data at the surface. So these are the rain gauge stations that we have used to study the trends of the rainfall events, which has minimum 40 years of the continuous rainfall to study the trend analysis. So here the second map explains about what are the trends in the total rain hours. Here we could clearly see over the central Indian region, the rain hours are decreasing when compared to the past, and also even the rain amount are also decreasing. But we could see the opposite trend that in the northwest coast of the India. So there is a contrasting feature that we have noticed for. So what kind of the events that exist? Like when we plot the rainfall event versus the rainfall distribution, what is the duration of that events that we have studied. So here we could clearly see we have divided the whole time period into two. One is from 1970 to 1980 and also from 2000 to 2010. We have divided the data set into two parts to study the climate change. In the first 20 years, here we could see the rainfall events with the rigorous rainfall events with minimum duration are not much when compared to the second decade. If you see the second 2 decades here, where even the rainfall with the duration less than 20 hours with approximately 150 to 200 mm of the accumulated rain events are increasing very rigorously when compared to the one. So it says that the shorter duration extreme rainfall events are increasing over the central Indian region. But this feature is not seen over the northwest coast of India. However, in the northwest coast of India, it is seen that the longer duration events are increasing with the vigorous rainfall. So we have studied what are the causative mechanisms over that, why this feature is observed over here. So one of the features that we have found was the background atmospheric conditions, like the instabilities, there is a change in that, and the total column water vapor, which had caused these differences for. So we all know mostly the rainfall comes from the passage of the depression, even like over this region as well. So we have studied the trend analysis for when the cyclones exist and for when without the rainfall without associated monsoon low pressure systems. This monsoon low pressure systems that we have considered for all the ones that starts from the low pressure to the cyclonic disturbances as well. Here we could see there is a decrease in the event frequency during the cyclonic period, which says that the number of the cyclones that is causing the rainfall over the central India are decreasing. So that's why that we could clearly see there is a decrease in the rain hours as well. But whenever you remove this and see the trend analysis, here we could see the event frequency is increasing for the normal days without the cyclones. Even though it is not significant, it says that the short duration events are increasing. So we have to analyze further. So here we could see not only because of the cyclones, even the localized systems are increasing with respect to time in the recent decades, which is most important and which is an alarming factor in the present day scenario. So this feature that we have compared with the CMIP-6 models, which is very important for the future projections as well. So these are the same, we have done it for the many CMIP-6 models, which has the high resolution data. Here I am showing one. In the CMIP-6 models, here one feature is very, very evident that in none of the decades it is not showing any rainfall events which is less than 20 hours. Like short duration events are not at all seen, that you could clearly see here, either in the first 2 decades or in the second 2 decades as well here. So it is not at all capturing the short duration heavy rainfall events. So some of the studies over the continental US and also the Australia by Dr. Westra and Dr. Allen has showed that this is not capturing because of the land atmospheric linkages are relatively weak, like especially the soil moisture that allows the rain systems to propagate. So we have decided to quantify how the response of the surface parameters happen during the extreme rainfall events. So the land atmospheric processes are very much important during this extreme rainfall events. So we have chosen one of the extreme rainfall event that occurred over Tirupati in 2021, which caused floods. Here you could see there is a huge floods that occurred in 2021 November. Like here you can see there is a complete floods not only in and around the Tirumala, in and around the Tirupati. So this is one of the anomalous event that you could see not only in the November for the past 30 decades, but also during the northeast monsoon. Here are the anomaly of the rainfall that is plotted. This is one of the rarest event that we have seen in 2021. So we thought we could quantify using this event. So this rainfall has occurred because of the passage of the depressions that is caused from the Bay of Bengal to the Tirupati. This line explains the location of the Tirupati here. The depression is passed over here, formed over here, and it is passing through the Tirupati region. During this event, we have received approximately 390 mm of the rain just within a span of 1 week. Like here, this rainfall is nearly 50% of the annual rainfall we generally receive. That we got it in just 1 week span of time. So this is a very anomalous event that we have seen. So we have quantified using the measurements that we have, meteorological sensors that we have at IISER Tirupati. We have the meteorological sensors at IISER Tirupati from the net radiometer. All the surface meteorological sensors are there. Like net radiation measurements, which measures the incoming short wave, outgoing, and also the soil moisture, heat flux, not only at the surface, but also at the subsurface levels as well. And also we have the Parseval disdrometer to measure the raindrops as distribution, and also the clouds to measure right from the surface to the 15 kilometers. So we have used all the data sets to quantify the event. So during the passage of this event, like we have the event from 10 to 12 November and also from 17th to 19th November. So we have quantified the surface net solar radiation diurnal variation and also the surface net thermal radiation diurnal variation over those periods. So and we have compared with the clear sky days. Whenever we have compared, the decrease is very huge from the normal non-cloudy days to this extreme rainfall event days. It is decreased by approximately 66.7% solar radiation is decreased. Hopefully you might have seen the dimming during the rain, but we do not might have thought about how much decrease it is. It is a huge, more than the half of that during this kind of events. And also the thermal radiation that is released from the ground is decreased by 74.4% from the non-cloudy days to this kind of cloudy days. So we just wanted to examine using the other independent data sets. So we have taken the ERA5 reanalysis data over the long term, like for the past 40 decades from 1979 to 2021, over the northeast monsoon rainfall, northeast monsoon season. So, and we have segregated the data to no rain days, rainy days, and as well as the extreme rain days, extreme rainfall days, and calculated similar diurnal variation. Even though the magnitude you can see for the net surface solar radiation and thermal radiation is not same when compared to these days, because these days whatever we have taken is over the shorter duration, but the percentage of decrease from the non-cloudy days to the extreme rain days is exactly more or less they are matching with each other. It says that the climatology whatever we are showing is varying. So the percentage decrease from the cloudy to the extreme rain days is same from the ERA reanalysis data for over the climatology that is showed for the many years, and also this is more or less similar. So similarly we have quantified the soil parameters as well. So we have the measurements for the soil moisture right from the surface, like 5 centimeter to the 50 centimeter subsurface soil parameter as well. So this topmost panel represents the soil moisture and also the rainy days. As I said the event occurred from 10 to 12 and 17 to 19. So that's why you could see there is a sudden shoot up in the soil moisture as well, and it sustained the highest soil moisture sustained for some time. So we have calculated the dry down curves for this and estimated the e-folding decay time, means how much it explains about the dryness of the surface soil. So here it is noted here. It is very clear that when compared to the normal events before, and we have compared, I am just showing for the one particular month here. So when compared to the normal events, it is after these events, the drying period is almost doubled at the surface, and it is still more at the subsurface 10 centimeters. 5 centimeters is shown, and also the 10 centimeters also. So it is taking more time, means the soil memory is increasing after this kind of extreme weather events, and it holds for a longer time when compared to the normal rain events that we see. And also the soil heat flux is also like here we could see over the soil heat flux also is very, very less, because of the soil temperature that is well known. The soil temperature amplitude is almost half when compared to the other days, so which has an effect on the heat flux as well. So we have quantified all these measurements, what is the effect of all these parameters during this event. So to summarize with, like this extreme weather rainfall events we have studied at the sub-daily scale, which is very important in the recent years, because this kind of events are increasing, and which are like relatively less captured in the CMIP6 models. And the analysis of the linkage, this kind of analysis of the linkage between land surface process and the sub-daily rainfall events is to be studied for the still more events. Recently we have seen when the cyclone Monta is passing through us, the same amount of the rain events we have seen, and the extreme rainfall events are more. So we'll be quantifying more. So I would like to request any collaborations, because this is very important over the different regions of the India. So if anybody is interested, I welcome you for the collaboration and discussion. Thank you very much. Here I would like to take an opportunity to thank the contributors of this work, especially Dr. Rajivan sir for providing us the huge data set of data set of rain gauges from the Indian Meteorological Department, and the encouragement and the discussions were very, very fruitful. And also Dr. Radhakrishna from NARL, and all the quantification from the IISER Tirupati work is done from by my PhD student, who has installed, who is there from the from the installation to the collecting of the data till today. Thank you all.
Thank you, Saikranthi. The floor is now open for questions.
Yeah, very nice study, Saikranthi. I read the paper.
Yes.
So my question is, soil moisture, of course, is responsible, we know. But the kind of things that is happening, say, 29th, 30th August in Chennai, or 23rd September, Calcutta, or even you saw 26th July 2005. So kind of cloud burst, 1 hour, more than 100 millimeter rain, right? So my feeling is that the CMIP6 model, if you analyze it is not, because the systems are coming from oceans, right?
Yes.
So where there is no land surface, right? It's a part of, even if you see our Kedarnath, all these events, so they are all extratropical, tropical depression interaction and so on. So my feeling is the CMIP6 is not at all capturing these synoptic disturbances. So this synoptic variance itself is completely absent, and the mesoscale process that is actually causing this heavy rainfall, those are completely absent in CMIP6. CMIP6 model and all the global climate models currently, they don't have the representation of the processes that is responsible to cause this type of cloud and rain. That is the current state of the art. So you and your students and everybody in India should actually put effort to make this model enable to capture these clouds and its processes.
Yes.
Otherwise, we have no hope
Yes.
in this climate change scenario.
We'll try. So actually one interesting feature what we have seen was, we had 2 events consecutively. The first event was not propagating much, but the second event was propagating spatially and as well as the temporally for a longer time. We have seen some of the studies, when the soil is wet and the system is propagating, then it allows the existence of the system for the longer duration. So this kind of things,
but systematic bias in CMIP6 model
yes, sir,
that it is underestimating all these synoptic variance.
Yes, I agree, sir.
But good study.
Thank you very much.
I have just one point. You show the data from 1960s onward,
Yes,
or
sir.
something.
Yes.
By any chance, is there any data even before that? Okay, what is my point is, cloud burst is one thing, but this flooding in the city, I think this is more or less man-made. We know that all this channel, etc., they are gradually, we are closing that. That's why flooding is that issue. So that's why, do you have the more data even earlier when this kind of urbanization not started, in that long period, is there any increase or the things?
Sir, I think IMD has, but why we chose from 1969 is to maintain the uniformity. We were studying about this.
My only point is that, let's say 1900 to 1950, do you see any trend of the cloud bursting, or this thing is increasing, some trend?
Yes, sir. It was studied. That's what I showed. Yes, it is 1900 to 2000. It was a extreme rainfall events, like I could say very extreme rainfall event with a magnitude greater than 150 mm per day. So it is studied by Rajivan sir. Here you could see there is an increase in the from 1950.
Yeah, so recent time that's
Yes.
okay, that's the okay, thanks.
Even before also, yes.
Hi, I don't know much about this field, so my question may be very naive.
It's
I'm
okay.
curious whether, so if you look at land use, land cover, India is really very fragmented, very patchy.
I
So,
agree.
like for example, across the world, generally parcels of land use are much larger, whereas in India, there's very, very, very patchy land use, land cover.
Yes.
So I'm wondering whether, is this in any way, could this in any way influence the kind of small scale, like the variability of small scale patterns that you see? Because if it's forest patch, small forest patch, very,
I
very
think at
small.
IASc the work is going on,
Okay.
but
Sorry,
I'm not
maybe
sure
this is not
about the result of that. When I was doing postdoc over there, I used to see whatever you have asked exactly, but I could not see them later then. I
Okay.
think of course it should be, according to me.
So, I mean, I'm just saying, if your question about global climate models, I was wondering whether the specifics of land use, land cover is very different in India, and that's why you have a lot of these very local events, which are very intense and short. But I don't know, maybe that's not the case.
Like major effect is from global warming, one of the one that we have seen.
I know that.
But
I'm
this
just saying-
land use,
Yeah.
land cover change, how much it affects the extreme, no, I really don't have the proper idea about it.
Okay, thank you.
Yeah.
This is a general question, kind of anti-correlated with main thrust of your lecture.
Yes.
How scientific are these efforts at artificial rainmaking?
Artificial
Rainmaking.
Okay. Sir, I think this is important too, because by knowing these processes, like say for example cloud seeding, if you know the cloud microphysics, rain making, like if you have more number of aerosols, and even if there is no water vapor, our cloud seeding fails. So I think if you understand better and do that in a proper way, I think it works. It is helpful. Yes. Thank you.
Ma'am, one quick comment and question.
Yes,
Question
sir.
cum comment. Your study is very important.
Yes.
You have talked about floods and so on and so forth. Cities are inundated with water. And this is not only north or south, almost every part in the country,
Yes, sir.
even Rajasthan.
Yes.
Question is, more than 50%, this is my humble submission with due respect,
Yes.
more than 50% problem is created by us, by human being. Why? Every city, if you look at it, prior to rain, the NDMC says all the desilting has been done, it has never been done. The water that goes, should go, is choked. When rainfall comes, water has to go
Yeah.
to the river. And mind you, in India, I do not exactly know, but I can tell you later, number of ponds which used to be there, number of lakes which used to be,
They are
they're
reduced.
all done. The builders have made buildings, the land have been sold.
Great.
We ourselves have created disaster without respecting Mother Nature. And today, no matter what we do, how much we cry, it's not going to solve. We got to be morally, socially, and then of course scientifically responsible for all this mess.
Yes.
Second point, which is very important, more important than anything else, is that if the river banks have been encroached, water has to find a way to go.
Yeah.
Cloud burst is once in a while phenomenon. In Uttarakhand, for example, if you have constructed houses after houses after houses on the area which is supposed to be reserved for nature, nature has no way to breathe even. What will then happen? Nature will take its action. So think of it. My humble submission to you is that find out how many ponds in the entire country in India with 147 crores population. These ponds have been encroached upon, the lands have been sold. This is true also for Kashmir, right? When
Yeah.
once we have the answer,
Maybe.
perhaps then person like we and you can manage to talk about the management and remedial measure.
Sure. Sure, sir, I'll do.
You agree with
I'll
me?
try. Yes, I agree.
Okay, thank you.
Yes, sir.
So, thank you,
you very
Saikranthi. Thank you, sir, for the comments.